My topic is parasitic computing. So today I'll be discussing about introduction, internet communication, implementation using TCP, issues, problem for parasites, problems for server, how it differed from other, future and summary. Parasite. What does it mean? Parasite means the one who depends on the other or the one who takes resources from the other. So, in a computer language, we can say that normal authorized interaction with one other program manages to get the other program to perform computation or solving complex problem. It is first reported in journal Nature in 2001 by Barabasi, Freach, Fiong and Brookman, a form of distributed computing used for complex computational programs. It basically exploits standard set of communication protocol on internet. Potential candidate protocol include TCP, HTTP, or encryption decryption with secure socket layer. So to learn how it communicates, first we need to learn how internet communicates. So in internet communication, we have two parts, sender part and receiver part. First, we'll discuss about the sender part, how it initiates the request. First, sender select an URL, after which TCP connection gets established. In that established connection, it issues an HTTP request. Then TCP's message is transferred. So user selects a URL actions, open a TCP connection to web server, issue an HTTP request over TCP connection, and TCP message is carried via IP, which is Internet Protocol. Now the message is sent by the sender side and how it function at the receiver side. So we'll discuss about now receiver side. It receives the message sent by the user through IP, validate checksum at TCP. If true, push to the HTTP or drop the packet. Receive message through IP, validate checksum at TCP, validated push to the HTTP, not validated discard the packet. Implementation. How we can implement this? Computation take place at many layers in the internet. Several internet protocols can be exploited to perform parasitic computation. Implementation made using TCP or higher level. So implementation using TCP. TCP checksum provide enough logic to compute any Boolean function. So it's just Boolean function, like if true then execute, else drop. And it mostly uses AND operator. In AND operator we know the Boolean table. If A and B are two inputs and both the values are 1, then only it's true. Otherwise it's false. HTTP service protocol always sends a response to any message received. So if we request anything to the HTTP server, it always responds, whether true or false. Checksum. What is the function of checksum? Checksum is to detect corruption of data. Checksum protect the packet from payload as well as the header. TCP checksum. TCP checksum sender break message into 16 word. These words are added together. The result is inverted and sends the message. Receiver break message into 16-bit word. All words are added together. If the result is all ones, the message is valid. Otherwise, the message is dropped. So we can understand in this way. If we have n bits, we can divide into 16 bits and n minus 16 bits. They are denoted as S1, S2, S3, ... and Sk. We take sum of all these. After that, the sum, and we perform the inversion operation on that sum, complement of that sum, which is SP, and then we can add SP plus Sk. And if it is true, then we can perform, and if it is correct, if it is not correct, we can drop. So this is the TCP IP segment used for parasitic computing. We have TCP checksum on urgent pointer. Before that, we have three layers: IP header, TCP header, or data. In TCP checksum, we know that checksum is used to detect corruption data. It basically validates. It protects the packet from the payload as well as the header. And what is the urgent pointer? Urgent pointer is basically indicate the priority to process the data. How we can create parasitic message? Variables values of possible solution are distributed. They will align when split in 16-bit words. TCP checksum sent is a representation of the expected answer. Parasitic checksum and variable string are sent to remote machine for verification. So how its algorithm works? So first we have to create a TCP segment. Then that TCP segment checksum is assigned with all the checksum. It basically iterate through all the checksum. Basically, it want to say that generate all the possible solution and stored in checksum. Then that data is padded with zeros. Then it is sent to send, and it is received, and after that, if answer is true, X writes a solution. So this is how it works. So this is how it works. We have one parasitic nodes, and we have different machines. We'll generate all the possible solution what we can generate. So, and we'll all the generated solution is sent to all the machines, and that machine validates the bits. If that bits are validated, we can perform our operation on that machine. So in diagram B, we have parasitic node and target web server. So in this parasitic node, we have different layers. One is network, IP, TCP, HTTP, and how they interact with how the interaction is between parasitic node and target server. It is basically through physical interface in network layer, and in IP, TCP, HTTP, it's through logical interface. So through IP, if the packet is correct, it validates from TCP. If the packet is correct, it pushes to the HTTP. So you can see with the red arrow, correct solution success. It means from HTTP, from IP to TCP, first it validates the packet and then it pushes to HTTP. On the second case, TCP package drops the parasitic node packages because the boolean value is false. So what are the problems for parasites? Problems for parasites. Several computation cycles are taken to process the all possible solution. As we have discussed earlier, we are producing all the possible solution. It's basically like brute force. We are producing all the possible solution, so we need to it take all possible solution to be executed or cross verify. So possibility of false negatives, possibility of false positive. Problems for server. What server side faces the problem? Delay due to processing the parasitic message could cause a denial of service because it take too long time. Almost impossible to prevent someone from running a parasitic job on your server. You cannot avoid it. Removing or changing the exploited function could cause the server to be unable to communicate on the internet. How it differ from the other? Cluster computing. Many computer pools their resources willingly. All the computer who are contributing, they know what they're contributing to. But in parasite, they don't know. Parasitic computing doesn't require willingness of the target machine. It is not cracking. Future. What is the future of this? Communication to computation ratio must increase. We must speed up the process. Exploiting HTTP or encryption decryption could execute in efficient manner. Enabling all computers to swap information and services they are needed could lead to unparalleled emergent behavior, drastically altering current use of the internet. Summary. So, parasitic computing moves computation onto what is logically the computation infrastructure of the internet, blurring the distinction between computing and communication. So, if we are given a complex problem, we can use some other resources. We can use resources of some other program and manages to get the solution from that program. So, we are using those resources. So it's all about parasitic computing. Thank you.